everybody, and welcome to our first coding tutorial for our threaded server. Now this is our server, so let us close it and let's name something called threaded.py. We start with the user bin Python and we will import right away all the libraries that we need. Since I already have the prototype of this program, I will just import everything right now and we will go through the code together while coding it. Now make sure to realize that first of all, this is not something that is properly coded, neither it should be. For as long as it really works, it doesn't really matter if we imported classes or imported anything else. We'll try to make it as simple as possible so that you can understand it the better. And then if you want to later on, you can just do some modification to the code for your own needs. We are not, once again, we are not the programmers, we are hackers, and all we want to do is get something to work. Then afterwards, if we want to, we can add specific modifications to it for our own needs. So we included our user bin Python line. Right now, let us import the needed libraries. First of all, we know that we are going to need our socket library in order to perform the connection, the binding, the accepting, and the communication between the targets. We also need the JSON library in order for us to implement our reliable send and reliable receive functions, which will allow us to specify any amount of data we want to be received and sent from the target PC. Next thing we want to actually import is the OS library, and the next thing is the base64 library. Now we know that the base64 we will use in order to, for example, receive images and so on and so on. Anything that basically is not a TXT file will crash if you do not encode it and decode it during the sending over socket object. And one last thing, but the most important thing for this project, right after socket, is the threading library. So we cannot create the actual threaded server if we actually do not import a threading library, which will allow us to do that. So, first of all, what we will start is actually coding the simple socket connection now, or binding the socket, however you want to call it. This will not be put into any function anywhere. This will simply be outside of any function. Let me just show you. We will start off by creating a global variable s. Now that global variable will be our socket object, but before we define the socket, let us create the two lists that I was talking about in the previous video. One list will accept or will get the actual IP addresses and binded ports to those IP addresses from the target, and the second list will get the socket descriptors that will actually define to who does which the socket object belong to. So IPs will be the list containing the IP addresses of our targets, and the targets will be the list containing the socket objects of our actual targets. Now we can actually create the socket object itself. It doesn't even matter. We will use the same as in our server. So socket.socket, socket.af_inet, socket.sock_stream. Same thing as before. So we want to use the IPv4 connection over TCP. Let's set the socket option. So set sock opt. We want to use socket.sol_socket and socket.so_vuse addr, also comma 1, and we created everything that is actually regarding our socket. All we need to do right now is bind a port and the IP address and listen for the incoming connections. So we already know how to do all of that. Of course, we are already familiar with everything. We need two open brackets and two close brackets, and we need the IP address of our Kali Linux machine, which is 192.168.1.9 in my case. In your case, you can check it out. And let's say we want to connect to the port 54321 as our usual port. This is our listening port actually. And now we want to listen for the incoming connections, and let's specify 5 connections for now on. So this is our socket creation. We will leave it just like this. All we want to do right now is make an actual function which will accept the connections while the rest of the program is running. Now this may be sounding a little bit complicated, but it really isn't once you really understand it. Basically what we will do is we will go up here and we will make a server function, so right here, and that server function will run a while true loop, and in this infinite loop it will accept connections. So what we can do is, first of all, in order to accept connections for a short period of time, we need to set this socket timeout. So s.set timeout, we can set it to be just 1 second, and then we can try and accept. What we will try is we will try the target, IP equals socket.accept. Now make sure to differentiate. This is not targets and IPs. This is just target and the IP. So in singularity, not really the list that we specified right here. Now, as soon as they connect, we want to append the target to the targets list, which we created right here. So currently it is an empty list. Let me just think about it. Yeah, it is an empty list right here. And right here, we append the newly connected target to the actual list. So, or not targets.target, we want to targets.append, and in brackets we need to specify what we are appending. The same we need to perform with the IPs. So IPs list.append, we want to append the newly connected binded IP with the port. Then we can print to the screen string from targets, and then what we need to do is find a way how we can actually pick a certain target from this list. Now we know that we can pick it with a number, so what we want to do is add a counter. The counter we can actually call the client, since at the moment at the beginning we can set the clients. So let's go down here. Clients variable will be equal to 0. Not cleanits, we need clients. So clients variable is equal to 0. Right after creating the socket, we don't have any target connected, and we can use the clients to be equal to 0. Then in our server function, we need to specify that we are using the global variable clients, and there, once we actually connect, once the target actually connects, we want to print the string from the targets list, from the element add the number of clients, which in this case will be 0, since our first target will take the element numberized under the number 0 in our targets list. Then after we print it, we will increase the clients by 1 for the next target that it might connect. So we close the brackets right here. We can print something like this. Doesn't even matter. Plus string from IPs, and then once again we want to use clients. Now, if you find this confusing, let me just see how many brackets I have closed and opened. 1, 2, 3. 1, 2, 3. Okay, everything is good. Now imagine something like this. Imagine our target actually has 2 pieces connected, or our server has 2 pieces connected, A and B, and also targets A and B, as we saw in the previous video once I draw it in the actual paint. Now, the actual clients will be set to 0, and this 0 client will represent the first client, which is client A, or target A, or however you want to call it. And then when A connects, we will print the session 0, which will be the target A, to be printed as it did connect. So we print it right here, print the string from this client, plus the string from the IPs of the client, and that means that someone has connected. So we can add it right here. Print string from the clients. You just see where I need to actually plus. And we can do something like this, has connected. Doesn't even matter, you can print it or you don't have to print it. It's not really that important. What is important is afterwards you increase the clients by 1. So we are increasing the clients, and then the next client, which will be client B, will take the element numberized under the number 1 in this list, and then we will print the 1, and then it will increase 1 once again, and then for the client C, and so on and so on. So that's the basics behind of this. Of course, in the except rule, we need to just pass. Since really we are not going to do anything in the except part, there is really no point, and there is nothing really logical to do about it. What is logical to do is, you will notice, since we will run this server function in a thread, we need to actually create a flag variable, which will be a boolean value, either true or either false. And what this flag variable will do is basically it will determine when this server function will close. Since this is an infinite function, we will never be able to close the program fully until we close this function right here. So in order to do that, we need to specify a value right here that will actually check, or not a value, we need to specify an if-else statement, which will check whether the flag is set or not. If it is set, we will quit the actual listening and accepting the connection, and we will quit the program, or our command and control center in this case. So let us make a variable right after the clients. We will call that variable stop threads. This is just a simple flag for our server function. We will set it right at the beginning to be equal to false, and then we will check in the while true loop in server whether it is set to be equal to true. So if stop threads is basically the same if stop threads is equal to true, then we want to break from this while loop and quit this server function. And all we are left to do right now is actually start a thread on our actual server. So let us go down here and let's type it right here. T1 will be the name of our thread, will be equal to threading.thread target equals server, and then t1.start. And basically we finish this server function. We will make a pause right now and we will continue in the next tutorial. Let us make a brief overview what we did right here. We created a simple socket object. We created two lists that will accept the clients or our targets. One of them will accept the socket objects. One of them will accept the IPs and ports. Then we created a simple variable clients, which will increase every time we actually get a connection. And basically, we also set the stop threads to be equal to false, and that is our flag, which will check when we actually want to close this server function after quitting the command and control center. We will set the stop threads to be equal to true, and then it will set this, it will check this statement right here, and then it will break out of this loop, closing this server function. Afterwards, at the end, right now, all we did was actually create a T1 thread that has a target argument of our server function, and we started that thread. So that would be about it for this tutorial. We'll continue in the next one, so hope you enjoyed it, and I hope I see you in the next tutorial. Bye!